will also belong to S, such that if and only if X star X inverse is equal to X inverse star X is equal to what? Identity element. So here, the operation is this. So we're having S inverse star S inverse triangle X will definitely be X inverse plus X plus 1, which is equals to our identity. So in this way, we have X inverse plus X plus 1 equals to our identity. So what is our X? X is our real number, so which is definitely going to be 7. So we have X inverse plus 7 plus 1 equals to the identity element, which is minus 1. So this is X inverse plus 8 equals to minus 1. So X inverse will be minus 1 minus 8. And our X inverse will now be minus 1. So that is the answer for that very question. I will go to our option and pick the one that corrects that, which is option C. Under mapping is also embedded in the binary operation, but it was not treated extensively just because you don't have much of it in the UTME. But also, it should be noted that this question was also tested in UTME. That is why I want to use this avenue to also talk about function, especially inverse function. So when I'm talking about inverse function, it is simply, we assume under this trend that y is equal to our function of x, so that we are interested in looking for function of x which is the same thing, y which is equal to function of which is the same thing as f y inverse. So this is what is known. And how is it calculated? The question will be given to you in function of x. So the first thing you have to do is to equate your y to that x. Then you now make your x the subject of the formula. After you have now made your y rather the subject of the formula, after you have now made your y the subject of the formula, then you now interpret everything back in terms of what? X. So what am I saying? Look at this question. Let me use it. It's a typical UTME question that I want to use as an example, because this, you don't have more of questions on this in the UTME. So, but just for a broad knowledge, that is why I've extracted this, so as to, in case you come across a question like this, you will know how to go about this. So this is a typical UTME question. So let's see this very question. So the question gave us that the function of our x is equal to 3x plus 4. So in this situation, the first thing we assume that let it be equals to function of x. Then in that situation, I will have y to be equals to 3x plus 4. The next thing I will do is I want to make my x the subject of the formula. That is the next step. So you transfer this one to this side, you have y minus 4 equals to 3x. Then the next thing to do is to divide both sides by 3. Divide 3x by 3. Also divide this one by 3. So then we have x to be equals to 1 over 3 into y minus 4. So here we can say that our y, which is equals to, then our y, which is equals to function of x, which is now equals to, which our y, which is equals to function of y inverse, which is now equals to function of x, will now be, in terms of y now, will now be equals to, in terms of x now, it will now be, since this is what we have, so in terms of x, it will now be 1 over 3 into, that means anywhere I see my y, I will replace with x minus 4. So we'll go to our option and see the one that matches this. So we come here, we discover that option C. So the topic now is matrices and determinants. Under this topic, candidates should be able to perform basic operations on multiplication addition, subtraction, and division. Then must be able to calculate, or should be able to calculate, determinants. Then compute inverses of 2 by 2 matrices. So in that situation, what we are saying is candidates should be able to perform operation, because we have matrices and determinants. So we have operations, addition, subtraction, multiplication, and division. So any question that is structured on this operation, candidates should be able to perform it. Then also determinants. We have, since we are operating, we have 2 by 2 matrix, 3 by 3 matrix. So if you are given 2 by 2, for example, let's say A, B, C, D, and you have to determine, let's say this is A, and the question asks you to determine determinant. If you want to determine determinant, determinant is always written like this. You have a slash A is determinant. So if you have to determine the determinant of this matrix A now, all you just need to do is to use this one to multiply this. That gives you AD. Minus, use this one to multiply this, and that gives us BC. So that is the determinant. That is how to determine determinant of a 2 by 2 matrix. Because 2 by 2 in the sense that row multiplied by column. So you have 2 rows, 2 column. So 2 rows, 2 column. That is how to determine the determinant of 2 by 2. So if it is 3 by 3, A, B, C, D, E, F, G, A, B, C, D, E, F, G, H, I. If you have this kind of matrix, let's N, and the question asks you to determine the determinant of, this is a 3 by 3 matrix. If you have to determine the determinant of a 3 by 3 matrix, the way we normally do it is to pick a center point here, you put it as plus, then we rotate it to minus, then another one plus. What am I saying? So you will resolve, we are going to break this or decompose this to 2 by 2. So how do we do that? We pick a point, plus A, then we close this place. We close this, and we close this. What are we going to be having? By the time we close this and close this, we pick plus A, we close this and we close this. We are going to have E, H, F, I, then we close it. Then we pick the second one, which is minus B. We close it, close this place, close this place. We have D, G, F, I. Then the next one, plus C. We close this place and we close this place. We have D, G, E, H. That's what we're going to have. So in that situation, we've succeeded in decomposing 3 by 3 towards 2 by 2. Then now we can now do it based on this. It's easy to multiply this. So we have plus A into EI minus FH. We have solved that. Minus B, that is DI minus G or FG. We do that. Then plus C, DH minus EG. So this is how to determine the determinant of a 3 by 3 matrix. Then compute inverses of 2 by 2. So if you are having, let's say A is, matrix A is A, B, C, D. For example, if you have to compute the inverse of this matrix, which is inverse of A, will definitely be 1 over, will determine the determinant of A, then over, multiply by, we change this, we change the leading diagonal and subtract So we are changing, this is the leading diagonal. So D comes to the position of A, and A comes to the position that you put negative to the other diagonal. What am I saying? The position of A now will be replaced by D, and the position of D will be replaced by A. That's the first thing. Then we put minus to the other diagonal. So this is how to compute inverse of a 2 by 2 matrix. So let's see examples to justify our claim. Let's see questions in form of examples to justify our claim. Yes. The first one says that SD equals to I, where S is this and our I is this. So automatically, you know that this one is product of matrix 2 by 2. So we have our ST is equal to our identity. And here, what is our S? Our S is minus 1, 1, 1, minus 2. Our T, let our T be A, B, C, D. And our unit matrix is 1, 0, 0, 1. So where T is A, B, C, D. So here, in this situation, we have to solve this, want to use to multiply this times this minus A plus this times this, that is C, must be equals to what? 1. Let's call this equation 1. Then this times this plus this times this, A plus minus 2C must be equals to 0. Let's call this equation 2. Then this times this minus B plus D must be equals to 0. Let's call this equation 3. Then we have this times this B